Hello, my name is Paul Yu, and this is the demonstration for PCM modulation. So to start, this is the input analog signal. Its frequency is 1 and amplitude is 2. This is the equation for the sine wave. This is the sampling rate for the sampling signal. So the sampling rate for the sampling signal, the sampling frequency for the sampling signal is the frequency of the input analog signal times with the sampling rate. Then this is the equation for the sampling signal, and this is the generation of the sampled signal. Then we have the quantization process. Here in the ENC variable, we store the encoded bits, and this is the setting for the number of bit encoding. Then here is the quantization process. For n equals to 2, which is 4 levels, we have this if statement and a for loop. Then in the 8 levels, where n equals to 3, we have the for loop with the if statement with 8 levels, followed by 16 levels for n equals to 4, and the for loop with the if else statements for 16 levels. And here we have the plotting for the graphs. Here we have the plotted graph for n equals to 2 and a sampling frequency of 10. This is the input analog signal, the sampling signal, the sampled signal, and the quantized signal. Since the sampling rate is 10, it can be seen that there's 10 samples here. Switching the encoding bit to 2, we get this graph. As you can see, the quantized signal is not very representative of the input analog signal. Switching it to 4, however, would produce a much clearer graph, as the peaks reach the expected amplitudes. Over here in the variables space, we can see that the encoded value for when n equals to 2 is here, where the first 2 bit represents the first sample, the second sample, the third sample, and so on. Changing the number of bits to 3 would result in the first 3 bits resembling the first sample, the next 3 bits the second sample, the third sample, and so on. Then switching it n equals to 4, we have the first 4 bits resembling the first sample, the second sample, third sample, and so on. Here we have the GUI for the PCM modulation. This is the input signal, the sampling signal, sampled signal, quantized signal. And here are the user inputs, which is the sampling rate, which will equals to the sampling frequency, since the input sine wave is f equals to 1, the number of bit encoding, and these two gauges show the current sampling rate and bit encoding. This set button is used so that the new settings can be used to plot the graphs. This is the code of the GUI. It is similar to the previous code, except for the addition code for the gauges and the input sliders. This is the GUI for the PCM. So we start with a sampling rate of 10 and bit encoding of 2. This is the resulting plots. Switching the bit encoding to 3, we have a clearer representation of the quantized signal, and switching it to 4, an even clearer signal as the peaks reach the actual amplitude, peak amplitudes. Switching it back to 3 and manipulating the sampling rate instead to 5 Hz, we have a lower frequency of sampling, hence a poorer representation. Increasing it to 7 Hz, we can see that a clearer sine wave has shown. Switching the sampling rate to 10 provides the best quantized signal.